first starts off with the function f of x equals cosine of x, and cosine of x equals -1. And I went ahead and took the first derivative because it asked for the first degree linear approximation, it asked for the quadratic approximation, and then the quartic approximation. And so I first did the linear approximation, which I explained it a little better. It'll be L of x equals f of x, and f of x equals 1 or -1 from cosine, and the L of x equals mx plus b. So you take mx plus b and plug in pi, because it gives you the coordinates pi and cosine of pi. So you plug in pi for the x, and I know the slope from the cosine is 0 at the point pi, so b equals 1, so Lx equals -1. I don't know why I wrote that. Yeah. And then for the quadratic, I did q of x, and then it's the formula for the quadratic, and then you have to do it all the way to the second derivative. So that's the steps to the second derivative. So I started out with the second derivative because it's the easiest to get for a. So a equals 1/2. Then I went to the first derivative, and it equals the f prime of pi equals 0. And that's from the first derivative. You get this, and you'll plug it in on this side, and then you got this equation right here. So it gives you 0, and then it comes out to b equaling pi. And then go to the original function, because I still need c, and you take the first function, which equals negative. Should be negative. Which equals -1, and it comes down to being c equals -1 minus 1/2 pi squared. And then for the quadratic function, you just plug in a, b, and c in their spots. So it will equal 1/2 x squared plus pi x minus 1 minus 1/2 pi squared. And then for the quartic, you have the formula for a quartic, which is ax to the 4th plus bx to the cubed plus cx squared plus dx plus e. So you're going to have a lot of work to do. And I took my first derivative, second derivative, third derivative, and fourth derivative. And then I always start out with the last one because it's easiest. So you take the fourth function, which equals -1 over here because it's that derivative, and then 24a, so a equals -1/24. Then I go to the third derivative, which the third derivative equals 0. So 0 is equal to 24 over -1/24 pi plus 6b, and b equals pi over 6. And then the second derivative, I did the same process for 1, and then I guess that's 12. Yeah, 12. Plugged in a, plugged in b, and to get c, which is 1 minus pi squared over 4. And then went to the first derivative, which equals 0, and 0 minus, or 0 equals 124 times this whole function, and D ends up negative 5 pi minus pi. Did I write that down right? Pi cubed plus pi. And then I went to the last one, which is a base function, and this one equals negative 1. And the whole base function, plugged them all in to get E equals negative 1 plus 23 pi to the 4th minus 10 pi squared over 24, which gives you the function of the quartic, which is negative 1/24 x to the 4th plus pi over 6 x to the 3rd plus 1 minus pi squared over 4 x squared plus negative 5 pi cubed plus pi over 6 x and plus negative 1 plus 23 pi 4 to the 4th minus 10 pi squared over 24, and it'll give you what it looks like on a graph. And here's 1, here's negative 1, and cosine goes like this, and here's pi, and you have the linear function, which is a tangent line, and then you have the quadratic function, which goes like this. And I don't know how to draw a quartic.
Quartic?
Yeah.
It actually looks a lot like the quadratic, it just fits the curve better. It's
Gotcha.
because it's, you know, like if you think of x squared and x to the 4th, right?
Gotcha.
It's x to the 4th is a skinny x squared, but if you change the coefficient, you could make it fatter. And so x to the 4th just fits it a little bit better. Let me throw a couple of things up here for those of you that are checking your work, because I know checking his algebra right here is not possible for me, but I have the power right here. So, his second degree polynomial, the second degree polynomial for this guy, he's got, this is good, it's a minus there, change it in red so you can see it. He's got a few algebra mistakes in here, but we don't have a lot of time, so what I want to be sure is that you walk home with the correct numbers so that if you go back and work it. And then it's negative 1 plus pi, 1/2 pi squared. So x squared over 2 minus pi x, negative 1 plus pi squared over 2. So you can check, the process is right, but he just got a couple of coefficients wrong. For the next one, amazingly, he did really, really well. I can't even check the, I can't check it all quickly because I'd have to get the common denominator here and mine didn't spit it out. But all right, that's good. And then pi x cubed over 6 is good. And then 1, this may, because we can get a common denominator here, this may be the same thing, but I'm going to write it the way the calculator does just to be safe. 1/2 minus pi squared over 4 x squared, and then pi cubed over 6 minus pi. Now that would be 6 pi, right? So you would have a negative 5 pi cubed. But I suspect you just did a little bit of algebra wrong combining those guys. Get it up there. Pi cubed minus pi x, and then the final coefficient is negative pi to the 4th over 24 plus pi squared over 2 minus 1. Now, if I put all these over 24, that may be what he has.
Yeah.
You with me? Because this would be 12. No, wait, 12 over 12, you have 12 pi squared. He's got, but then, oh, this might, no, I'm not going to do it. Anyway, that's the right way to give Taylor series. Okay, so let me be sure here that, let me make a couple of comments. One, I think that Jesse made his life a little bit harder than he had to. I think you'd find it much easier if instead of approximating e squared, you just left it as e squared. I think you'd find the whole problem easier if you just said what am I starting with? I've got L of x, which is mx plus b. That's what I want. I just need to find m and b, right? And f of x is e to the x. So like he said, f prime of x is e to the x. F double prime of x is e to the x. So f of 2 is e squared. F prime of 2 is e squared. F double prime of 2 is e squared. L prime of x is m. Oh, we don't need that double prime, do we? Just do it first. L double prime of x is m. So what's L prime of 2? M. So when you set L prime of 2 equal to F prime of 2, what do you have? M equals e squared, right? Okay, so now I know L of x is e squared x plus b. But I also know that L of 2 has to equal F of 2. So e squared has to equal 2e squared plus b. So b has to equal negative e squared. It's actually easier if you just leave them like they are. So L of x becomes e squared x minus e squared. Right. Everybody sees the process of setting the, no, and he's got to be a little bit careful here. Brandy's going to dock him because cosine x isn't negative 1, right? What did he mean when he wrote this? Cosine at pi, right? He really means L of x is this, so, or f of x, I guess. Those are actually f's, aren't they?
Yeah, it's supposed to be.
I think this is still doing the f of pi is cosine of pi is negative 1. And then f prime of pi is sine of pi, which is equal to 0, right? That's what you need to figure out, is all those values at those places. Then you've got to set them equal. Okay, go back through, make sure. That's one of the things you're going to expect to do on the test, is find the first and the second worst case scenario if it's a wild card, a third Taylor polynomial from scratch. Or you can type it into your TI and it'll spit it out in 2 seconds flat.
I couldn't work.
This is L of x, so L of pi is supposed to be yes, he was mixing his F's and his L's, definitely up here, right. So F of pi is cosine pi, negative. So m pi plus b has to be negative. Then we have to find
what is the first step?
Which is again that
What is the first degree approximation?
So b just becomes negative 1.
You ready for that?
Oh, we doing it. Y'all doing Cal2 today?
Ready for that, sir?
Yep, left your line.
Yeah.
We got some extra.
That's
I gotta back up.
Yeah, well, you question. As soon as the paparazzi.
You're going.
Study?
Huh?
Study?
Yeah, about to go right now.
Man, I'm happy to do it.
Okay, what you have, Tyler? Oh, sorry.
Is this the first step? So, I don't know what step this is.
Okay, so the first step should be, you doing the second one or the first order or second order? Which one do you want to do?
Alright, hold on for you. That's for.
Okay, that's what you're probably doing. So, if you're trying to find the second degree approximation, right? Just
You just go.
Yeah.
Something from second degree.
you've gotta have at x equals pi, right? That's what's important.
That's given.
Then you gotta have f of pi has to be q of pi. F prime of pi has to equal q prime of pi, right? And f double prime of pi has to equal q double prime of pi.